Already it's open, it's kept open. So this is the fifth module what we're supposed to discuss. So fifth module says it is transducers and PLC. These are the two topics, and one more topic is instrumentation amplifier with transducer instrumentation amplifier. One is the transducer is the first topic, second one is the instrumentation amplifier, and third one is the PLC, programmable logic controller. So these are very important topics which are very much useful in your power electronics. And once we learn this particular topic, what is the outcome of that one? The major CO is design the principles of operations of digital instrumentation and PLCs. Means how exactly a digital instrumentation can be designed. What are the parameters you have to consider? Okay, what are the principles which are used to design the digital instrumentation? That is what we are going to learn with respect to this particular unit or this particular module. In this, we will be learning about introduction about the transducers and what are the electrical transducers which are available, what are the resistive transducers and resistive position transducers, resistive wire strain gauges, resistance thermometers. You might have heard about thermometers, thermistors, LVDTs. All those things will be discussed one by one. And when it comes to the next topic, that is instrumentation amplifier, we'll be discussing about the temperature indicators using thermometers, analog weight scales, everything. And when it comes to the last topic, that is programmable logic controller, structures, how exactly PLC structure comes into picture, how the PLC will work, what are the operations, what do you mean by relays, what do you mean by registers. All this we'll be learning. Okay. Moving ahead. So generally, what do you mean by transducer? What is the uh, definition of a transducer? A simple definition says that a transducer is a device which converts one form of energy into the another form. So a simple example which is given in this slide showing we are having a audio signal which is supposed to be received by microphone, and finally it will be amplified or controlled, or unnecessary data has to be removed, and finally it will be delivered through an actuator called the loudspeaker. Any audio which is generated, which is produced, which will be received by the microphone, and then it will be amplified as per the requirement, and finally it will be sent to the speaker where anybody can listen to that. So one form of the signal is being converted into another form of the signal. That is what transducer work at or operations. So in this one, whenever you consider a transducer, we should be having a sensor, we should have an actuator to perform on that one. So sensors and actuators are the input and output transducers. So example of the transducer, we can directly say that one, sensors are the input transducers and actuators are the output transducers. When it comes to sensor, it can be a passive device or it can be an analog device also. What do you mean by passive? It can be active device also. It can be a passive device, it can be active device. It can be analog or it can be digital. See, when it comes to a passive device, what do you mean by passive device? A passive device like changes resistance. You want to change in resistance where it can change. It can be active device where output is the voltage or current level. So it's just example it's showing over there. If we want to measure the voltage or we want to measure the current, an active sensor we are going to use. Similarly, when you want to change the resistance, you can go for the device. Just 1 second, let me have. So any issues? I think no issues where the session is going smoothly. So here the diagram, the image in simply it can explain that, or it will show you how exactly a transducer is going to work. Okay, an input device is a sensor. In between, we are going to have a control system. Later, at the end, we are going to have the output device, the actuator. So, first and foremost, as we have discussed the topic, there is electrical transducer, there is a resistive transducer is also there. First thing is we should know what you mean electrical transducer. Then only we can go for the next topic. Here, the electrical transducer says is one which converts the non-electrical quantity into the equivalent electrical quantity. Like audio signal is there. That audio signal, what we are producing, that will be received by the microphone, and that microphone will convert that one into electrical signal. Okay, a mic which will receive the audio signal, and that immediately it will be converted that into equivalent electrical signal. That is electrical transducer. No electrical quantities such as force, displacement, stress, temperature. That is, these are all the data which are non-electrical quantities, like it may be a force, it may be a displacement, it may be stress, or it may be temperature. So electrical quantities such as current and voltage. So it will be converted into the non-electrical quantities will be converted into electrical quantity. That will be done by your electrical transducers. So what are the parameters electrical transducer will consider? Electrical transducer have the following is having the following parameters. One is the linearity, another is the sensitivity, another is the dynamic range, repeatability, physical size. Just check the questions what I have framed in your assignment. So a simple question: list out the parameters of the electrical transducers. List the advantages of the electrical transducers. Like that, a simple direct questions have been framed over there. So there may be a question on just simple list where you need to list it out, or there may be a brief explanation is required. So depends the questions. You can check it out. A question is also here only. I'll show you that. See, electrical transducers. Let me go directly to define electrical transducer. Question number 18. List out the different parameters of the electrical transducers. See, the question 18 says that define electrical transducers and list the different types parameters of the electrical transducer. For this one, two slides here. Just this is the first slide. Yeah, first slide. This slide has to be written neatly. You have to explain that one. Next one is the parameters. This will fetch you a minimum marks. Okay, just people are still waiting in the lobby, I think. Yes. So just read out the questions. Based on the questions, you can come out. These entire slides, if you read, it will be easy for you to answer your question as well. Next, coming to the advantages and disadvantages. Advantages. What are the main advantages of the electrical transducers? Electrical amplification and attenuation can be done. See here. Whatever the signal we have received, non-electrical signal, that will be converted into electrical signal. First point. Now, once it has been converted into electrical signal, what we can do? We can amplify it or we can attenuate it. That is one of the biggest part or biggest advantage of your electrical transducers. As per the requirement, we can change it. If it is very low, we can amplify it, or if it is very high, we can attenuate it. Both can be done. Mass inertia minimized. So if it is any inertia is there, or total inertia, that is mass inertia, can be minimized. Friction effects can be minimized. So once it has been converted into electrical signal, if any friction inertia is there, that can also be minimized over there. Output can be indicated remotely. So whatever we are going to receive that one, we can send it to remote location. It has been converted. We have received the data here. Assume in the classroom I have received the data, but that can be remotely we can send. Anywhere we can send that one. That is the advantage with respect to electrical transducers. The signal magnitude can be related in terms of the voltage and current. That is the main advantage. Whatever the magnitude we are going to have, whatever the signal we are having, it can be converted into electrical signals like voltage and also current, and we can measure them in voltage or in terms of voltage, in terms of current also. The signal can be conditioned. It is conditioned actually. The output can be easily processed. So these are the main advantages. There is a question, what are the advantages of electrical transducers? So 1, 2, 3, 4, 5, 6, 7. 7 advantages. Easily you can write it, you can get the marks for that. Electrical transducers can be classified into different two types. That is, one is active electrical transducers, second one is passive electrical transducers. In that one, resistive transducers, inductive transducers, capacitance transducers, electromagnetic transducers, photo emission transducer, photoelectrical transducer, photoresistive transducer, frequency generation. So these are the types of the classifications under passive. Now moving ahead, selecting a transducer. How we can select the transducer? We have some data. We have some different types of data. We have to select them. Okay. Sensitivity is one of the parameter we need to check by, for selecting the transducer. Frequency response and resonant frequency. So what is the frequency we are operating? How much frequency we need to operate? What is the range of the frequency? That is of the one of the parameter we need to check into before selecting the transducer. Environmental compatibility. Yes, very, very important. Assume there is a transducer which can work in that particular environment, because some of the transducers we cannot put them into water and we can operate it. So conditions need to be checked before selecting the transducers. If it is required, a transducer which need to work in the water, inside the water, because I need to receive the signals. I need to receive some input underwater. So what are the uh, securities we need to have? How exactly we can procure the device? Everything we need to select that one. So environment, it should be environmental compatible. Then only we can select that one. Accuracy, how much accuracy it can provide, whether it's 70% accuracy, if it is acceptable, 80%, 90%, or sometimes we need 99.95% accuracy is required, or even sometimes 100% accuracy is required. So if that is the case, what type of transducers we need to select? Usage and ruggedness, very, very important. Sometimes we need to place the transducer in a remote area, or some maybe inside the water 24/7 we need to put into, or near fire we should keep those transducers. Some unavoidable circumstances we need to keep them. So if all those things need to be checked, we have to verify what type of transducer we are supposed to select it. Similarly, electrical parameters also need to be considered before selecting the electrical transducers. So that is with respect to electrical transducers. Next one is resistive transducers. The first one, passive transducers. A transducer whose resistance varies because of the environmental effects. Such type of transducer is known as the resistive transducer. Very simple. The transducer whose resistance varies because of the environmental effects. Such type of transducer is known as a resistive transducer. The change in resistance is measured by the AC or DC measuring devices. The resistive transducer is used for measuring the physical quantities like temperature, displacement, vibration, etc. See, a temperature, your thermometer. What happens as the thermometer is kept on the body, the environment? As the body temperature changes, definitely your transducer will give a different output. So, a resistive transducer changes with respect to the environmental condition, environmental effect. So that is one thing. Displacement, vibration. Vibration also we will be having that. So looking into the resistive transducer. The principle of the resistive position transducer is that the physical variable under measurement causes a resistance change in the sensing element. See here, we have kept a shaft, a wiper, a coil, conditional strips, construction of a resistive position transducer, how exactly we can measure. So it is a, previously the olden days we used to have a rheostat. Now what we call a variable resistance box we are having known. decayed resistance box, what we are calling now. Previously, we were having a coil-based resistance. There is here on the right side, we are having a coil and we are having a variable movement. We are keep moving over there. This is swaft, a wiper. We keep moving on the left side or right side. We keep on moving over there. So resistance can be changed right from the left to right. We keep changing the ones. Okay. So the condition strip, conducting strip, swaft will be there. See, swaft is keep moving left to right. That's what the arrow mark indicates over there. So where exactly it is getting contact, based on that one we are able to measure the resistance. So resistance starting from point A to point B, point A to point B, if it is very close to A, resistance is less. If it is keep moving towards the B, resistance is keep on increasing over there. Based on that one, we are able to measure the resistance. We are able to check what is the resistance of that particular device. The principle of resistive position transfer is that the physical variable under measurement causes the resistance change in the sensing element. Currently, we are not using this type of resistometer, that is rheostats, in any of the campuses. Previously, we are using. Previously, we are using just we are keep moving over the conditioning strip and also shaft. Conditioning strip only I used to call. We keep moving over there. Based on that one, we can verify, measure it. A common requirement in industrial measurement and control work is to be able to sense the position of an object or the distance it has moved. See, that's what I'm telling. Position of the object or the distance it has moved. Based on that one, we can measure what is the resistance we are having over there. This is one more type of the resistance. Resistance wire strain gauges. If a strip of conductive metal is stretched, if the strip of conductive metal is stretched, it will become skinner and longer. Both changes resulting in an increase in electrical resistance end to end. That is what I am telling. As you keep moving or keep stressing, then it changes the resistance from end to end. Conversely, if a strip of conductive metal is placed under compressive force, if a strip of conductive metal is placed under compressive force without buckling, it will broaden and shorten. Either it can broaden, it can shorten. If these stresses are kept within the elastic limit of the metal strip, the strip can be used as a measuring element for physical force, the amount of applied force inferred from measuring its resistance. Yeah, there are some interpretations, some disturbances during classes. Many people are keep on sending some or the other messages and keep on disturbing the classes by calling. That's why I'm getting disconnected frequently. So, since you need to join the other sessions, my one suggestion is I need to share the screen once again. I'll just share the screen and I'll finish up the session. But see to that maybe maximum number of classes I will be taking this week. Not only classes, even though those who are missing the classes, those who are missing the classes, kindly go through this video. See here, I'm playing a video. Are you able to see the screen? Hello?
Yes, sir.
Yes, sir.
Yeah, just one second. I'll last few minutes. See here, there is a VTUPEI. VTUPEI is there. This one, there multiple videos are available. This is especially with respect to fifth module. So they have
by
explained in this one what I mean by it.
of the energized input, and then it has been transferred into the transmission media, generating its related energy in one or more systems. Like some might be the transmission media will be different, but what we are expecting the output is the specified input what we are measured, and that has been converted depending on the what is the input and what is the output from the categorized on that we can classify. Usually, it is having a physical quantity, or it can be measured in terms of a electrical one, or it might be a electrical input, and we can expect a mechanical output, some kind of a movements or any kind of the energy.
One thing I would like to uh, inform you. See, if you go through this video, here not only the list of the parameters, each parameter has been explained in detail. What do you mean by linearity? What do you mean by sensitivity? What do you mean by dynamic range? What do you mean by repeatability and physical size? All these things I've just listed out in my slide. But go through this particular video where you will be getting in detailed information. In detailed information, you're going to get that one. So everyone has to watch this video. So multiple videos are there, one below the other, like 10 minutes, 20 minutes, 16 minutes, like that. So it will be useful for you. It's a Canara Engineering College, Mangalore video. It is there. Watch them thoroughly, or download or share with your friends, those who are having, discuss with your friends. Hardly another 3 4 days are there for your IA. By that time you have to be ready for IA. So watch these videos when you are free. Go through them. Easily you can answer all the questions which are there in the question bank. Okay. So that is one thing. I am not finding one more video which is from the Mysore college. That's why I am selecting this one. Here also it is there. Fourth module, fourth module and fifth module, both you can watch these videos. It will be helpful for you. Okay. That's all from my end. Any queries, any questions from your end, you can ask so that you can relax and then you can join for the next one. Someone once again started my meeting. The session is already over. You can go to the next subject. Maybe DSD subject will be there. Okay, kindly close this meeting and you can join the next session.